We're looking at a law of cosines problem that gives us all three side lengths this time. We see side, side, side. That's what this SSS stands for. It's saying that we have all three sides provided, and we see that they're asking us to solve the triangle. And the first thing to remember is, what does that ask us to do? And that just says, hey, there are 6 pieces of information in a triangle typically. There are 3 angles and 3 sides that we usually think about. And so what I'm going to do is I'm going to go in and I want to evaluate what all 3 of these angles are. We know all 3 sides, so we don't have to worry about that. And that actually restricts us to a single form of law of cosines. In fact, let me just go ahead and jot down the first one. The measure of angle A is cosine inverse of big A squared minus B squared minus C squared all over negative 2 BC. We saw this in the last video. We saw it in our formula video. All we have to do is literally plug in the numbers we were given and just move on. The only part to be careful about here is to remember that little a is always across from angle A, or whatever corresponding variable you're working with. So this little 6 up here is little a, our b is the 14, and our little c is 9. So all I'm going to do is plug these values in. We have 6 squared minus 14 squared minus 9 squared all over negative 2 times that 14 times that 9. So that's something that we can go to the calculator to find out. And what I like to do most of the time, if I know I'm going to use the calculator more than once, and my problem's individual parts, my individual components don't rely on each other. What I mean by that is I don't need angle A to find angle B. I'll wait to go to a calculator. I'll just come down here and say, look, let's go ahead and just set up the rest of the problem. I don't want to do anything too crazy here. This form is just going to swap what goes first. So with big B, we'll start with little b, and then we'll subtract a squared and c squared all over negative 2ac. And this is just a matter of plugging in values. This is nothing too crazy. So this time we lead off with the 14 because that's our b squared, minus our 6 squared minus our 9 squared, all over negative 2 times 6 times 9. And there we go. We can find the measure of angle B. Now make sure that we're careful about a couple of things. One, don't waste your time writing out the same formula set up for C. It's a lot of extra work to plug something like this into the calculator when I know for a fact that the measure of angle C is simply going to be 180 minus the measure of both other angles. Remember that in a right triangle, or sorry, not just a right triangle, in all triangles, that you can take 2 angles, subtract them from 180, and you can find the third angle. They must all add to 180 degrees. So, and again, that's all triangles, not just right triangles. I had a misstep with my mouth there. So this is the part of the problem where I can go in and just grab a calculator and finish this thing up. So let's do that very quickly. So again, a warning I'll put in any video where I use a calculator with angles. I want to make sure that whatever calculator I'm using has degree mode. So here I've already selected that just to save time. If you're on the Google calculator, there's a degree and radian button there. If you're on Desmos, there's a radian and degree button under the settings options. So just make sure that you take care of that before working on these. But otherwise, inverse cosine, we're just going to go ahead and plug in some values. We have 6 squared minus 14 squared. And actually, let me put in an extra set of parentheses here since I'm not using fraction bars here. 6 squared minus 14 squared minus 9 squared all over negative 2 times 14 times 9. All right, now that's going to tell me that I get about 16.99, and we are measuring angles. I like whole numbers for that usually. It's not always perfect or required, but that's what I'm going to go with here. We're going to say approximately 17 degrees. So here we are. We got approximately 17 degrees for one of our measurements. So we'll go back over here and we'll do B. And I'll take this one a little bit more careful. I'll go ahead and put the fraction bar in, which you can do on both Desmos and this sort of calculator. So here we'll type in 14 squared minus 6 squared minus 9 squared. Then on the bottom we'll do negative 2 times 6 times 9. Now I use times down here instead of the parentheses because it's less keystrokes, less to plug into the calculator. And always double check. I went a little fast on the first one, but it worked out. just make sure you don't type something in wrong here. It's worth comparing this back to what you have written down. But here we're going to see we get about 137 degrees. So the measure of angle B is approximately 137 degrees. So we'll go ahead and box that in as our second answer. We said that there were three answers, so we just need to find what 180 minus 17 minus 137 equals. And we'll just be a little lazy here. We'll go ahead and just plug that into the calculator. Minus 17 minus 137. Again, make sure there are no typos. It's easy to slip up and go, oh, this is super easy, and just take the answer and hope it's correct. We're seeing that the measure of angle C, let's go ahead and say it's approximate, since we use rounded values, is approximately 26 degrees. And there we go. We have solved our triangle. We have all three angles that we needed.